scientist, pillar of the India's advancement test and evaluation system. Dr. Roy presently serves as the additional director, integrated test range of Chandipur. Yes, sir. So. Okay, sir. Thank you.
Eyes are in the front. My leader has told we don't do that.
Yes, sure, sir, sure.
Unfortunately, we are standing in the world of natural stupidity and talking about artificial intelligence. What I mean to say is that you understand Einstein never wanted whatever he created to be used. So there is our natural stupidity, and you are having good picture of it now going on, and there we are talking about this world of electronic warfare, electromagnetic spectrum dominance. Basically, this is a dominance on sin. What I mean to say, this is the electromagnetic spectrum. All of you, even in the school, you know, and of it, the ionizing part of it is ultraviolet and beyond. And luckily, people are at least thinking about not using the ionizing for weaponization. A part of it is being used in your nuclear bombs as all this gamma rays and all, and you know about it. The non-ionizing, why it is because in the ionizing one, a single photon, the simple equation of E is equal to hc by lambda will 13.6 electron volt and above, and it is able to ionize anything in your body. So you will be not lived with the person you are. So for that, we are entirely having the dominance in the non-ionizing world, and even the ultraviolet, we screen it through filter so that it should not burn our screen. X-rays and all, we control the doses. Gamma rays, all of you know, and cosmic, what to say. But I want to say, bring into your domain that our space electronics needs radiation hardened electronics material and radiation hardened processors and computers. All that, sir was here. Sir is telling, we are, sir, both pieces of bread only. The cheese is you in the sandwich. And if we make a gun, we need you to fire. So none of us are less important. What is there is that we use all part of the spectrum. The word multispectral is being told once or twice here. We use all part of our spectrum just to have sense the what is happening, and base sensing is passive sensing. If I do active sensing by radiating and all, my enemy will also take my signature. All this electronic intelligence, signal intelligence, all the intelligence will come into picture. The passive sensing is absolutely through this domain of visible and infrared. We know that wherever our cameras will not work, we have to take the thermal side of it, and somewhere in my slide I'll show that a visible camera and a thermal camera, what they can reveal and what they cannot. So we are having this entire gamut of UV beyond. left to us to sense and the fight the war. Now one day, a student has asked to Dr. Kalam, ki you are such a brilliant person, a person of high humanity, why do you build missiles? The basic answer he gave is that you are a boy, you tell me you want to be strong or weak. He said, no, why I should be weak, I should be strong. And that is what I am doing for the country. So, this is where we have the entire space of frequency, what we are using, and all of them are being utilized in some form or other for communication, radar, seeker. Ma'am, other day, ma'am, though we are from, ma'am is from CSIR, we are DRDO, but we are co-workers somewhere. So this is the synergy we talk of, and today is the platform is that earlier we always say our R&D, academia and industry, there is a air gap. And where we are bridging it and overlapping now. I am working with ma'am for certain things also. And I want to say that many of the things like ma'am was asking something 94 gigahertz, what it will be utilized. I said, ma'am, first utilization is seeker. 94 gigahertz is a very high frequency. So we talk of all these radars and missiles and mid-course guidance. Then finally it comes to a seeker, or a boy was asking somewhere about electronic flies. He was not able to coin the word. There is something called electronic flies, which are smaller drones, are like mosquitoes, and how they could be killed. So for that, so here are the different gamuts which we are using, and here I want to bring you one thing. Say, direct energy weapon. Sir has explained you very well, taking a lens and burning the paper and all that. What we are doing, ठीक है, ड्रोन आ रहा है ना, इसमें लेजर मार के इसको जला देते हैं, ठीक है. Now I will tell. If you are a mechanical, you are very outstanding people who are standing out, but you can sit down somewhere. Huh? Okay. See, some mechanical guy asked me, it is all cyber and electronic warfare. Where do I stand? I said, you stand, because you will make a drone of lightweight composite material which will not be burnt by laser. Simple. What is not done in the world is left for you. So for that, and I want to say is that sir has rightly told GDPs and all that, and sir has told us we are the optimistic guy. Yes sir. What I want to say is that Britishers has taken one Kohinoor from us. US has taken all the CUs from us. Till now, we are able to land in South Pole of Moon. And we are able to defend in Op Sindur. So for that, our advantage is that we cannot revert. Our advantage is that our average age is 28 or 29. Whereas China is 38, 39, or Japan is 48, 49. And European and US also in the 38, 39 stage. We have having 40 crores of youth, and some of these Kohinoors are sitting here. So what I mean to say is that, suppose this NIST is very strategically located. It is between Bhubaneswar and Vizag. And what is that? Think local and go global. You can produce, you can think, design with us, and have a startup here. There are different kinds of funding. Some other day your HR can discuss what are the funding means. So something can be very well designed out from here. And technology development is not TD now. It is think differently. Because the war is to wit and outwit, fooling the others. Nothing like, and it is a hands down war. That's why we want robot or autonomous system to fight. We don't want to kill our people. So for that, so if it is a direct energy weapon of sir told HPM, which is microwave and laser, I will ask some of you, I know there is a company in Bhubaneswar, they are doing wonderful drones, IG drone, and they are ex-products of University Burla College, who founded that. So for that, and there is, my friend out here is there, Milan and Rajiv, they will tell you that this part of Odisha is only giving the targets for all the testings in integrated test range. So every place and every person, if he is thinking something, he is not, as sir told na, no reverse engineering, no copycat. So only if you as an engineer, you think and contribute, you will have a lot of things to do for the country. And yes sir, if our worth will be good enough to increase our GDP with our number, that time we are looking for next 25 to 30 years or 2047 or something like that. So here, if it is the effect of all the ionizing radiations, and they are also useful because you need to develop radiation hardened electronics, and many of them are utilized for space electronics purpose, and some of them are also utilized for like XRD. Any of your mechanical guys or meteorology guys know what is XRD, X-ray diffraction, and they find the composition of the material through that. And but we know that we give the X-ray in doses because it can ionize, and similarly UV rays. But what we are going ahead is from here to there. What I mean to say here to there, you must have, all of us might have seen this particular antenna somewhere in life. Satellite antenna जैसे दिख रहा है उधर लेफ्ट में है, and उसका बगल में जो है वो it is radiating. इसको अगर देखना है तो ये घूमेगा तो थोड़ा टाइम लेगा. अब मैं बोलूंगा कि घूमने का टाइम में वो एयर डिफेंस का अंदर वो आके आपको मार के चला जाएगा. अब मैं क्या करूं? I want to see everything together 360 and up to certain height. अगर वो 30 किलोमीटर तक फ्लाई कर सकता है तो उतना तक देखना चाहता हूं. So for that I need a kind of a system which is a phase array systems. You can have 4 of them or you can have a band of them, and cover switching of electronic beam from one to other. Ma'am has got his PhD on that. So you can switch the beam. And nowadays it has come, even if, as you told, no, sir was talking about least jam frequency. What is least jam frequency? I will put a signal generator or say a spectrum analyzer. You people will be slightly hard of it. In the spectrum analyzer, I can see the spectrum of others. So when I see the spectrum of others, I found that this is your dominant frequency, but still you are using some least dominant frequency called least jam frequency like it is. So I will try to use your least jam frequency, my weapon. Or I have to do the frequency hopping from F1, F2, F3. Now, earlier days when frequency change or frequency hopping was planned, it is planned in the same band. Like in the S band or C band, you will have many frequency hopping. But Nowadays, innovative concepts are coming up. If it is a phase array system, you know there is a lambda by 2. If anybody of electronics person is there or MTech in microwave, there is grating lobe. इतना distance होना चाहिए दोनों element में, तब जाके वो switching हो पाएगा, वो phase array radar बन पाएगा. हम क्या करेंगे ना, S band का दोनों को बीच में एक KU band का पैटर्न लगा देंगे, फीडिंग अलग से करेंगे. So back plane only feeding, because feeding has to match. So for that, a single system will work in 2-3 different band, and also what it will do is that it will have time division multiplexing of the band, so that there are two ways of looking at it. Is that either time division multiplexing, maybe you can sit down somewhere, otherwise your legs will have difficult. So one is that time division multiplexing, is that you look for 10 millisecond this band, 10 millisecond this band, or like that. Or otherwise, if S band is for long range, you pick up through X band, hand it over to C or X band, or if you have a seeker to, or you have a layer of air defense to fire, then you go to KU band or anything beyond that. Still, we have problem to encounter like this. So as you told dominance, there are many antennas and all band, all frequency communication radar, and when you have multi-band radar, you have a problem like this. This scenario tells that in this you have the multifunction things to do, search, you have to find the threat and threat alert, acquisition, track, investigation and classification. What is classification? What you are tracking is a aircraft or it is a tactical missile or ballistic missile, TBM. You have to classify. How do you classify? You classify with their speed or height at which they fly. A ballistic missile will have a typical speed bracket, and so the RCS of aircrafts will have a RCS bracket. So all these are used for your classification to say that which kind of air defense weapon you need to use against them. So for that, your coverage should be 360, and normally nobody comes above our head 90 degree. If elevation 70 degree is there, it is big enough to support any kind of a air defense system. But you need to do all these things of engagement and ECCM, electronic countermeasure, and electronic countermeasure. Whatever measure you will take, I will take opposite to that. So this is how the air defense moves on, and this goes through analog beamforming and digital beamforming techniques. In the analog beamforming, beam shape, switching of beam is possible, but changing the beam shape instantaneously is difficult, which can be achieved through digital beamforming. Give some coefficient, the shape of beam also will be changed. So this is how where your computer is giving power to EM also. So for that, and these are the typical way, how do we go about a TR module, transmit receive module, and a phase array systems, and you just generate the frequency from a signal source called synthesizer, upconvert it, and then transmit through a branch. And underwritten antenna controller, and if you want to do it digitally, the DDS is direct digital synthesis. If people are little bit MTech level, they understand. So I just want to give you a picture of it, that these are the areas. And on the receive channel, you can also have an analog kind of receive channel, and you can have a digital kind of a receive channel, and only if it is digital receive channel, the cost will go high and all that. So for that, these are the ECM, ECCM, different features, like you have, like one is called side lobe banking. Any of you know antenna? You have a main lobe and a side lobe. Like this, a main lobe is the main one, by the side of it, it will have small lobes, which will be maybe 13 dB down, 14 dB down, like that. So your side lobe banking or side lobe cancellation, because somebody can trace you if you are doing something on the main lobe, and somebody can trace you from your side lobe also. So for that, these are the different kinds of techniques which we are doing just to have dominance. As sir told, no, in the radar field now we tell it is space to, you don't know that ground probing radar system. There is radar system utilized to understand कि आपका अंदर गोल्ड है या लोहा है, ये मिट्टी का अंदर, ग्राउंड प्रोबिंग जीपीआर. So for any kind of systems, we now develop that capability to have it, and this is a typical system of a phase array air defense radar systems where you try to detect this. Now it comes ma'am's area. I did everything, but ma'am did something different. Ma'am told, इसको stealthy बना दूंगा. कैसे करूंगा? Now either there are three methods: put a RAM over it, radar absorbing material, or you decrease, you make it spiky. स्पाइकी होने से क्या है, आप अगर प्लेन देंगे तो हीट होके आएगा. स्पाइकी होने से जो इधर लगेगा वो जाएगा ऐसे, आपका तरफ कम आएगा, ये आएगा ही नहीं. So all this kind of shaping is done, and she works in RCS mainly, and this to make it, we have identified which one is giving how much of returns, and after that we make it like this. बाबा वो दिख जाएगा, उसको छोड़ो, ऊपर बनाओ. And somebody was rightly pointing out that we are not yet developed the air engine. Sir, Kaveri, some high altitude failures are there, but STFE, single fan turbo engine, is developed and flying now. Maybe Kaveri will be sorted out. Someday we'll be out of GE or Rafale. So this is kind of, see, a typical car gives you a radar cross section of 100, whereas a aircraft like F-22 Raptor is giving you a RCS of 0.0001. So you have this problem. Now you bright people have to develop signal processing technique. What is signal processing technique? I am very fortunate that you have such a experts. VC Saab has gone all over the world. What is the signal processing techniques is that if it is a very small signal, how you want to just gather, integrate, amplify and detect. So there lies your engineering capability. So thereafter, as sir told, D4 system, I am just expanding those 4 Ds: deny, degrade, damage, destroy. If drone is flying, we'll deny it and we'll degrade its capability, we'll damage it, not fully, if fully, then destroy. So this is how the D4 system has worked in Upsindur, and yes, our laser weapons were having telling effect on short range, but this is where we need multispectral things. See, left side is a day image, okay? So there you see, and right side, वहाँ में वो डे इमेज में इतना अच्छा बढ़िया कलर दिख रहा है, बट लेफ्ट साइड में जो ट्री है उसका नीचे कोई खड़ा है, दिख पा रहे हो आप? But it is not there. But if you see the IR image of it, you are finding the person who is just below the tree on the left side. But what you are losing? आपका वहां पे पहाड़ दिख रहा था, अब नीचे तक आने तक फॉग आ जाने से पहाड़ भी नहीं दिखेगा, ऊपर थोड़ा थोड़ा दिख रहा है. But you lose some of the informations in the visual, some in the IR. So there you need a fused kind of, like, next. See, here I have given 3 pictures. One you see is that is a visible image picture. Then you have a IR picture and a fused picture. In the visible image there is no cloud. In the IR you have cloud. But the visible image, आपको वो जो विंडोज एंड ये देखिए उसमें भी डिफरेंस है. एंड कार, दिस जीप इज स्टैंडिंग और द इंजन इज ऑन, दैट योर थर्मल कैन टेल. So these are the multispectral requirement where we go from RF to terahertz. Ma'am, we are trying up to 330 gigahertz, but we are still limited up to 94 gigahertz. And because some are S&T experiments and some are technology development experiments and some are technology development by industry. So we have to classify in that way. So this is how your support systems in the air defense should work. It would detect the enemy radar. What we did is that, as sir told, space is the next front. So what we did is that कि स्पेस में लो अर्थ ऑर्बिट सैटेलाइट लगाए और उसमें एक डिजिटल एक रिसीवर लगा दिए, एक वाइड बैंड रिसीवर, और उसको क्या करे, जब वो पास कर रहा है, we know that some person is telling we don't have very friendly neighbors. So when we are passing over them, we are trying to capture their all electronic signatures passively through our digital receiver. And that can be given to our AWACS as a stand-off operating frequency measures. AWACS is early warning platforms. We have platforms like Emperor with Netra. We have IL-76 platform with our Falcon Israeli radars also. Our radars Uttam from gallium arsenide has gone to gallium nitride mode as a Mark 1 to increase its range. So if we want to create a kind of a jamming, we need to know their operational frequency and power. That is, we are trying to go to sky and pick up, because it will have some pass over them at some period of time, and we are picking up correctly. उसको calibrate भी करना है ना, वो हमारा ऊपर जब जाता है हम उसको रेडिएट करके बोलते हैं कि मैं कितना में हूं बोलो. अगर ठीक से बोल पा रहा है तब जाके वहां का जो किया है वो भी ठीक है. So like that we jamming the enemy radar through our EW systems, deception techniques like वो सामने लोग जानते हैं कि चाप और फ्लेयर डाल देते हैं. चाप is nothing but aluminum foil डाल देते हैं to detect them, and these are some of the deception technique. And one of the most important is that digital radio frequency memory. क्या करेंगे कि वो जो उसका सिग्नेचर है उसको डिजिटल मेमोरी में रख लेंगे, उसी को ही हम एम्पलीफाई करके उसका ऊपर छोड़ेंगे. So these are some of the techniques we are adapting, and we are quite in a good position to take care of it. So these are some of the methods we are adapting: DRFM and frequency hopping. and encryption, shielding. See, first of all, one is that कि वायरलेस में आप जितना अच्छा करो कोई भी कहीं आपको पकड़ लेगा रेडिएट जब कर रहे हो। तो क्या होता है, ऑलवेज प्लान ये होता है कि जो हमारा अंदर वाला एरिया है दैट शुड बी ऑलवेज वर्ड विथ फाइबर ऑप्टिक्स हाई बैंडविड्थ। मे बी लास्ट माइल में अगर हम लोग कर नहीं पा रहे हैं वायरिंग, it should be wireless only so that it will have a low power, so detection capabilities are less. So for that wireless, your high power means someone or other will pick you, you cannot shield it properly, encryption or whatsoever. So these are some of the systems. We have Netra currently, Netra Mark 1 on Embraer and on Airbus 321. It is our next generation Mark 2 is coming. Falcon system is actually a integrated by India system. First one is fully indigenous by us and others are the equivalent systems of the world. So with this, if you have air defense, you have improves your survivability, disrupts enemy and enhances mission success. Why our adversary has to run to the Akka within 3 days to stop the war. So for that, but return is complex system, high cost, requires advanced signal and data processing capability. So with this, the future trend is AI-based EW. Why AI is that I told that we want that it should be hands down winning. Like we don't want to play the human. आप बच्चे में खेले होंगे ना, वो जो एक छोटा सा डॉल आता था उसको गिरा देने से वो फिर खड़ा हो जाता था. So our soldier should be like that. If he has hit point blank also, वो ऐसे गिरेगा फिर ऐसे खड़ा होगा. That is the robotic soldier. Okay, so for that AI-based CW, cognitive radar. So we will take the signature of all the armament and our complex signature of the enemy and make our radar cognitive. Thus इतना दूर में है ना, तुमको यही दिखेगा, इसको कैंसिल करना, उसको छोड़ के जो दिख रहा है उसको मारो. So what हम किसको छोड़ना है, that will be decided through the cognitive sense of this radar system. And autonomous, as we all want, and space based is the next gen. And anything, what I did is that I tried to stay with you for 1.5 days. Up to my colleagues are also here. So anywhere the students and the organizers needs any kind of, because you might have seen sir was helping me कि मेरा पास book पहुंचा है कि नहीं. So we work together like that. So for that I am here for 1.5 days. So now question during lunch anytime is open to you.
Any question from the audience?
Radar cross section. Radar cross section is the amount of energy that is reflected back. आपने यहाँ से radar से इलेक्ट्रोमैग्नेटिक एनर्जी छोड़ा, वो जाके वहाँ पे लग के वो इधर वापस आएगा एंड कुछ स्कैटर भी हो जाएगा. वो जो वापस आता है उससे हम जानते हैं कि ये कितना टाइम में गया, कितना टाइम में आया, तो कितना दूर में मेरा एग्जिस्टिंग है. सो राडार क्रॉस सेक्शन डिफाइंस कि वो कितना ज्यादा एनर्जी मुझे देख रहा है. वो क्रॉस सेक्शन को कम करने का काम स्टेल्थ ने करता है कि क्रॉस सेक्शन ज्यादा होने पर वो इजीली डिटेक्ट हो जाएगा. सो बॉम्बर जब बनाते हैं हाई बॉम्बर्स, दे ट्राई टू रिड्यूस the cross section by having more edges and putting the radar absorbing materials. And but क्या होता है कि इसका भी एक लिमिटेशन है. वाइड बैंड, कभी कोई वाइड बैंड सिस्टम को जाम करना इजी नहीं होता. बिकॉज क्या होता है कि वो राडार एब्जॉर्बिंग मटेरियल बनाएंगे, वो शायद एक्स में काम करेगा, सी में काम नहीं करेगा, एस में दिख जाएगा. सो फॉर दैट, सो फाइटिंग इज गोइंग बिटवीन the material people and the electronics people. You cover, I discover.
Thank you, sir. Thank you. Sir rightly said, TD is not technology development, but it is thinking differently. Our president usually says the same. Disruption is the law of nature. We have to go for it. Thank you, sir, for your invaluable contribution in enhancing the defense research value. Thank you.
Thank you, Akanksha.
Thank you, sir. Thank you, all the keynote speakers.